10.1, we're going to be talking about area of parallelograms. We're getting into our geometry unit. I just need us to be able to define parallelogram. A parallelogram is a quadrilateral that have opposite sides that are parallel. Quadrilateral means that we have four sides. So the definition of a quadrilateral is that we have four sides. Getting even more technical, we say all sides are polygons. And when I say polygons, it means that it just has straight edges. We don't have any curvature going on. Okay. Some of the major parallelograms that we will be working with. The common type of parallelograms that we are going to be working with are a square, a rectangle is another parallelogram. Opposite sides are parallel. There's two pairs of opposite parallel sides. And a rhombus is another type of parallelogram that we will work with. Some students have said trapezoids before. Keep in mind that a trapezoid, we do have a set of parallel sides right there, but the opposite sides are not parallel. And for it to be considered and defined as a parallelogram, opposite sides must be parallel. We're going to talk about heights of parallelograms next. The heights of parallelogram, they need to create a 90-degree angle with the base. That just means you need a height, you need to stand nice and tall. So you're looking for a dimension that's straight, creating a 90-degree angle. As 7th graders, what you're going to notice is the state will try, in the book, will try to trick you to make sure that you can identify what a height is. And what you're looking for, and I'm doing this first example here, is a 90-degree angle with a base. Okay, and when I look at my base here, I have this line that created a 90-degree angle. That would represent our height. Another characteristic of height is it usually connects the top and bottom bases. Looking at this example here, now keep in mind that any side here on this parallelogram could be considered the base. And when I connect my opposite sides, I created this perpendicular angle, 90-degree angle, and so that distance represents my height. Or we could have it where we take a vertex of the parallelogram and we just drop it straight down to create our own 90-degree angle. That would also be considered the height. Keep in mind that everything is opposite of what we are defining as the base. So this vertex is opposite of my base. This, where I dropped my height down, is opposite of my base in that second one. The first one, I'm given my base, and I'm going all the way down to my second opposite base, and that's what created my height. The formula for an area of a parallelogram is equal to b times h. The b is our base, and the h is our height. So what you're going to be required to do today is to be able to specify what dimension represents your height and what dimension represents your base. We'll go right into an example. This first parallelogram, first off, look at how they represented the base two separate ways. They went from this bottom vertex and dropped it straight up to the opposite base, and we got a height of the 8 inches. Here they went from the top, the second example, and they dropped it down to the opposite base, and then just kind of put a dotted line to just represent that it is perpendicular to the base. It's aligned with where the base would be. Either way are accurate ways to describe your height. Area is equal to B times H. Our B here is 3.5 times our height is 8. That's equal to an area of 28 inches squared. Now keep in mind that all area is squared. The next example, finding the area of this little parallelogram. Again, area is base times height. My base looks like it's 3. My height, I can tell because I formed a 90-degree angle, is 2. So I am 6 meters squared. Looking at the next one, I have 8 inches is, I would call my height because it's representing for me going from one base to another with a 90-degree angle formed. So my area would equal my base times height. My base is this 3 times my height is my 8. That's 24 inches squared. And that's the extent of the practice. I did notice that as students were starting their homework with this lesson, many were struggling with some converting, so I'd like to go over some examples. And I'm just going to do number 5 with you. I want to find the area of this rectangle. That doesn't look like a rectangle, but it is. And I have 3 yards by 15 feet. Now I can't start combining them yet. They need to be like units. It's just like combining like terms. When you start multiplying things, you need your units to be alike. And I have a yard and a feet. So what I either want to convert my feet to yards or my yards to feet. It really doesn't matter how you want to do it. Whatever's easiest for you. But my conversion factor is I know there are 3 feet in 1 yard. So if there are 3 feet in 1 yard, I can either convert my feet to yards by dividing by 3, or convert my yards to feet by multiplying by 3. I usually like to convert from my big to my small because then you usually just have to multiply. So this turns into 3 times 3, which is 9 feet. If there's 3 yards and there's 3 feet per yard, that will be 9 total feet. So my area is going to equal 9 times 15, which turns into 135 feet squared. One more example from your homework where we have to do a little converting. I have 100 centimeters. This is not a square. Looks like a square, maybe it is. So I have 100 centimeters and 1 meter. All right, and looking at this, if you can recall from your 6th grade science unit, we had this strategy where you went King Henry died unexpectedly drinking chocolate milk. And you can utilize that for anything with the metric system. So again, it doesn't matter what I choose to convert, like which one I choose to convert to. I usually deal with, again, meters goes in our unit. So if I wanted to convert from 1 meter to centimeters, all it's really doing is moving a decimal. So if I'm right here, it's like a 1 point for meters, and I want to go over to centimeters, I move my decimal 1, 2 spots, and I get 100 centimeters. Now maybe someone wants to see me redo this. If I wanted to go the other way and convert my centimeters to meters, if I'm at centimeters and I'm at 100, my decimal is right here, and my goal is to get back to my main unit. I would go back 1, 2 spots, because centimeters to units, you go 1, 2 spots, and I get a 1. So, that's a little recap, very small mini lesson on doing some converting. Alright, I like to go from my meters to centimeters again. I erased it so I have 1 meter. If I'm going to centimeters, I need to go 1, 2 spots. Bring in the decimal 2 spots. So it's 100 by 100, which turns into 10,000 centimeters squared. And that should be plenty of examples for you to do the rest of your homework independently.